Let us study types of chemical reactions. There are 4 types of chemical reactions. They are combination reaction, decomposition reaction, displacement reaction and double displacement reactions. Now one by one we will study. What is meant by combination reaction? Combination reaction is a reaction in which 2 or more reactants combine together, a single product is forming. That reaction is known as combination reaction. So in combination reaction there should be 2 or more reactants. Then they should join together, a single product should form. Then that reaction is known as combination reaction. Here few examples I written. NH3, that means ammonia, reacts with HCl, that is hydrochloric acid. As a result of it, ammonium chloride, a single product is forming. Then we can say this reaction is known as combination reaction. Second example, here magnesium reacts with the oxygen. Magnesium oxide is forming. Here 2 reactants combine together, a single product is forming. We can say that here magnesium reacts with oxygen, magnesium oxide, a single compound is forming. Then we can say this is an example of combination reaction. Here now this equation is a balanced condition. That means this is also a balanced equation, but here balancing is not required. Why? Because here nitrogen 1, here also nitrogen 1. Hydrogen here 3 plus 1, 4. Here again 4 hydrogen. Then chlorine here 1, here also chlorine 1. Here now this equation also a balanced equation. All equations are balanced here. Here now 2 Mg here, here also 2 Mg. Then oxygen here 2, here also 2 oxygen. So we can say that here 2 reactants, that is magnesium as well as oxygen, combine together a single compound. We can say that magnesium oxide is formed. Then we can say this is an example of combination reaction. Now other example. Here this is again an example of combination reaction. See here calcium oxide, CaO, calcium oxide reacts with water. As a result of it, a single compound formed, that is calcium hydroxide, CaOH twice. Along with that, heat liberated out, heat released out. So we can say that when calcium oxide reacts with water, calcium hydroxide along with that heat liberated out. So we can say this is again an example of combination reaction. Now we will study about what is meant by decomposition reaction. Decomposition reaction is a reaction in which 2 products are or 2 or more products are formed from a single reactant. Then we can say that that is an example of decomposition reaction. Decomposition reaction is a reaction in which 2 or more than 2 products formed from a single reactant. A single reactant. Here again a single reactant. 2 or more than 2 products are forming from a single reactant. Then it is known as decomposition reaction. Here now you see C12H22O11. We can say this is the formula of a molecule of sugar. Just we have to heat a sugar molecule, we have to heat it. As and when we heat it, we will get 12 atoms of carbon and 11 molecules of water will get. So we can say that here 2 or more than 2 products are forming from a single compound. Then we can say that is an example of decomposition reaction. Here the symbol of heat is shown. Other example, here again 2 or more than 2 compounds, or we can say 2 or more than 2 products are forming from a single reactant. Then we can say that is again an example of decomposition reaction. Here calcium carbonate, CaCO3, calcium carbonate, just we are heating it. As a result of it, calcium oxide as well as carbon dioxide is forming. So we can say this is an example of decomposition reaction. Now this is H2O2. This compound is known as hydrogen peroxide. Hydrogen peroxide. Here H2O2, that is hydrogen peroxide. This hydrogen peroxide decomposes to water as well as oxygen. Here we have no need of supplying heat. This reaction, the conversion of hydrogen peroxide to water as well as oxygen, is a very slow process. It is taking place in the atmosphere or in the nature. Very slow process. We have no need of supplying heat to it. Even though conversion of hydrogen peroxide H2O2 to H2O and O2, we can say that this is an example of decomposition reaction. Why? Because from a single compound, two or more than two products forming reaction will be there. Then we can say that that is an example of decomposition reaction. Here actually two products are forming. Then also it is an example of decomposition reaction. Now here this is a balanced chemical equation. So two molecules of hydrogen peroxide slowly changes to two molecules of water and one molecule of oxygen. Now we will study the other reaction, that is displacement reaction. What is meant by displacement reaction? Displacement reaction is a reaction in which the place of the ion from a less reactive element in a compound taken by another more reactive element by formation of its own ions is known as displacement reaction. Here with example we will study now. Here copper sulfate CuSO4. Copper sulfate reacts with iron, iron. As a result of it, iron sulfate as well as copper forms. Here CuSO4. Here Cu is the metal. Fe, this is iron, is a metal. Now here iron is more reactive than copper. Now at present with the copper, iron sulfate is joined. So we can say that this is copper sulfate compound. It is a less reactive compound compared to this iron. So we can say that the metal copper is less reactive than iron, or we can say iron is more reactive than copper. As a result of it, this ion is taken by iron. This ion SO4, SO4 2 minus. This is sulfate ion. Fe, that is iron, IRON. It is a metal. This is the ion. So this ion receives or takes sulfate ion and forms its own ion, that is FeSO4. Here you are seeing that CuSO4, but here after the chemical reaction you are finding that FeSO4. Then copper separates. This copper sulfate from that copper separates. Here iron a single was there, now iron sulfate formed. So we can say that here iron single but here copper single. So we can say that this is the example of displacement reaction. One more example. Here copper sulfate reacts with the lead. Pb means a lead metal. Lead. This lead is more reactive than copper. As a result of it, lead receives the sulfate ion. As a result of it, lead sulfate formed and copper separated. So we can say that this is an example of displacement reaction. Lead sulfate, LEAD, SULPHATE. Other one, iron, IRON, iron sulfate. CuSO4, that is copper sulfate. Now, here we are going to study about the other reaction, that is double displacement reaction. Now, what is meant by double displacement reaction? Displacement reaction is a reaction in which the ions, here we can say chromate ion, CrO4, here SO4 ion, then here NO3 ion, here Cl ion. So we can say that the ions present in the reactants are exchanged. So here we can say that SO4, here CrO4. Now CrO4 will go to here, SO4 will come to here. So we can say that here in case of double displacement reaction, the ions which are present in the reactants exchanged and form a precipitate. Here products are forming. Out of these products, one will be a precipitate. What is meant by precipitate? Precipitate is a solid substance, we can say. It cannot dissolve in water. So we can say that it will be insoluble in water. Precipitate, it's a speciality. It is a compound. It is a ionic compound. It is an example of ionic compound which cannot dissolve in water. So similarly here also we can say this is a ionic compound means what? That is a metallic compound. Now here two metallic compounds are there. This barium chromate is there and potassium sulfate is there. Barium chromate also a metallic compound. This is again a metallic compound. So we can say that both of them are ionic compound. Here also you can see metallic compound, both of them are ionic compounds. But speciality, this will dissolve in water. This ionic compound will dissolve in water. This ionic compound will dissolve in water. But this cannot dissolve in water. This cannot dissolve in water. So in a chemical reaction, if one product is unable to dissolve in water, so we can say that a precipitate is formed. Similarly here, silver chloride cannot dissolve in water. So we can say that here also in this chemical reaction also one precipitate formed. So such a way, in the product if there is one precipitate as well as these two, that means reactants are there. There in the reactants which all ions are there, they are exchanging with each other. We can say barium sulfate, SO4 go to K2 side. You can see here K2CrO4 is there. This CrO4 going to barium. Then barium chromate becoming. Potassium chromate changes to potassium sulfate now. Similarly, here barium sulfate changes to barium chromate. Similarly here silver nitrate changes to silver chloride and sodium chloride changes to sodium nitrate. That means these ions are exchanging. So ions which are present in the reactants are exchanged, as well as in the product one precipitate is forming. Then we can say that that reaction is an example of double displacement reaction. Now we will study what are exothermic reactions and endothermic reactions. First we will study the definition of exothermic reaction. Exothermic reaction is a reaction in which heat is evolved out or heat is released out. then we can say that is exothermic reaction. Now what is meant by endothermic reaction? Endothermic reaction is a reaction in which heat is absorbed, or we can say that we have to supply heat. Then we can say that that is an example of endothermic reactions. Here few examples are given. You have to find out now which are coming under exothermic reaction and which are coming under endothermic reaction. Here you see product side. When we are seeing product side if you are seeing heat, then we can say that they are the examples of exothermic reactions. So here we can say heat is in the product side, here product side heat, here product side, here product side, here product side. So they all are, easily you can be able to say that they all are exothermic reactions. Now endothermic reaction also, some examples. Here now some examples easily you could find out. Similarly here also endothermic reaction easily. Some examples very easily you can find out. Wherever heat is there in the reactant side, they all are the examples of endothermic reaction. And where heat you are supplying, heat you are providing, that is also an example of endothermic reaction. Here reactant side heat is there, here reactant side heat is there, then here we are supplying heat, here we are supplying heat, so we can say that that is the example of endothermic reaction. Now where we are having no marking of heat, then whether they are coming under exothermic reaction or endothermic reaction, we will see. The first one we studied as endothermic reaction, second one exothermic, third one exothermic, fourth one exothermic, fifth one reactant side heat is there, so this is the example of endothermic. Now product side heat is there, so we can say that this is the exothermic reaction. Now here ice, conversion of ice to water. Conversion of ice to water means we have to supply heat to ice. So we can say that this is an example of endothermic reaction. Endothermic reaction. We need to supply heat to ice. Then only ice will transforms to water. Now here water converted to ice. So here now what is there? From the water we have to remove the heat, we can say. We have to remove the heat into the atmosphere. So we can say that this is the example of exothermic reaction. Water transforms to ice. So how water will transforms to ice? When we remove heat from the water, then that heat will go to the atmosphere. Then we can say this is an example of exothermic reaction. Now other thing, cooking of food. When we want to cook food, we have to supply heat to the food material. Then only food will be cooked. So when we supply heat to the food material, cooking process will take place. So we can say that this is an example of endothermic reaction. Why? Because we need to supply heat. Now burning of candle or lamp, anything when it burns, so heat is coming out. So we can say this is an example of exothermic reaction. Now here already we studied in the product side heat is there, so exothermic reaction. Here heat we are supplying, so we can say endothermic reaction. Here heat supplying, endothermic reaction. Now we are going to study one more topic, that is when we wanted to convert concentrated sulphuric acid into dilute sulphuric acid. Whether we have to pour concentrated sulphuric acid into the water or we need to pour water into the acid, that is the question. So I will explain to you now. So now we have to convert concentrated sulphuric acid H2SO4 to dilute sulphuric acid. We have to take one glass container. We can say now an example like beaker, glass beaker we have to take. Now in that we have to put one glass rod. This is the glass rod. Now how much quantities of water you have to convert to dilute sulphuric acid? That much quantities of water you can take it in this container. This is the water. We can say required quantity as per your requirement, how much acid you need to make it. That much water you can take it in the container. After that you have to pour little by little concentrated sulphuric acid into the water. We can say that drop by drop sulphuric acid, concentrated sulphuric acid you have to pour into the water. Then as and when we add concentrated sulphuric acid into the water, we have to keep on stirring it. Just we have to stir the solution. As a result of it, there won't have any splash as well as splatter in the liquid. There will be no splash, no splatter in the liquid. We can say that the reaction will be a slow process. Slow in the sense means it won't be a vigorous process. It won't be a vigorous process. Now, vigorous process means what? If we are pouring in the boiling water, boiling oil. Now just imagine in a pan we kept oil and the oil is in very hot condition. In that if we pour water, so such a way splash as well as splatter will occur. Vigorous reaction will occur. Even you can find that oil comes out. Same way will occur if we are pouring. Just imagine here now acid is there, concentrated sulphuric acid is there. In that if we pour water, then we can say that such a vigorous reaction will occur. All acid will splat or splash on us. Then that will be highly dangerous. Even full body may get burned. As a result of it, means very dangerous reaction may occur. So when we convert concentrated sulphuric acid into dilute sulphuric acid, we have to take care that inside the water little by little concentrated sulphuric acid we have to pour it. Then such a way vigorous reaction won't take place. Even if or as and when you pour little by little, then stirring process should be done. Then we can be able to protect us. Thank you.